Hi. Today I think we're going to start talking about some logarithmic properties that help us solve logarithmic equations. In the last lesson we solved equations that had the same base. Today we're going to look at just some other ways that we can manipulate logarithmic functions so that we can solve equations. The first two are pretty straightforward and not too complicated. Let's look at this first one. This first one says log base b of b is equal to 1. And that is a little confusing to look at, but when you look at it in exponential form, it makes total sense. Anything to the first power is just itself. So if I write out an example of this log, I might do something like log base 6 of 6. And because anything to the first power is just itself, I know this is going to be equal to 1. So that's pretty straightforward. If I were to write it as an exponent, writing it as an exponent would look like 6 to the first power is equal to 6. Better use my right column. There we go. So that's just how we can use that particular property. And as I said, it's pretty straightforward. So that's groovy. If I look at the next one, it's equally straightforward. Well, in logarithmic form, it says log base b of 1 is equal to 0. Makes total sense if you look at it in exponential form. Here we're saying anything to the 0 power is just 1, and hopefully that's familiar. So write it as a log. Log, let's say base 9 of 1. We know that that is going to be equal to 0. And if I write it in exponential form, we're saying that 9 to the 0 power is equal to 1. And that makes sense. If I look at these examples down here, I'm going to tackle this one. I'm not going to do all the examples in this lesson just because I think some of this is pretty straightforward. I'm going to skip to example 2. And I'm going to say that because this is 2,574 to some power equals 1, I know that power has to be equal to 0. And if I write it out in exponential form, then sometimes that's easier to make sense of. The 0 power is equal to 1. So as I said, those are pretty straightforward. Let's move on to something a little bit more interesting. The next property we're going to talk about is the product property. This property tells me that if I have log base b of 2 terms being multiplied, that is equivalent to log base b of the first one plus log base b of the second one. And you can have any number of terms in here, and they will all be strung together in an addition statement. This only works, though, if your logarithms all have the same base. So that's pretty important to remember. Let's look at an example. I'm going to write an example that looks like log base 3 of what? Let's try 2xy. All right, so if I write this as separate logs, what this property is that I can write log base 3 of 2, and I can write plus log base 3, and I'm going to eventually need another one because there's 3 terms. So I'm just going to go ahead and write out my logs because I'm color coding and it's a pain to pick up the pens 9 million times. So that's all this property is saying, is that I just string out the logs as an addition statement. As I said earlier, I'm not going to do all of the examples. I do want to talk for a moment about what the word condense means. When we see the word condense, what that's telling us is we're going to make smaller. So I'm just going to put a little note over here telling us that when I condense this, it's making it smaller. So that's what I'm going to do here. Notice I have 2 logs that have the same base and they're being added together. So this property tells me I can write them as one statement. I can write log, I keep the base, which in this case is 6, and this is telling me, our property tells me that instead of adding the two logs separately, I'm going to write them together as a multiplication statement. So it looks like this. Log base 6 of 4 times 9. Well, we know that's really just, I'm going to write it again, log base 6, because we can multiply that, and y'all will do that in your head because you're brilliant. And so if I use my product property, I can rewrite this example 5 as log base 6 of 36. Sometimes, as in this example up here, we are done right there. Sometimes we can evaluate this. And in this particular case, yes, we can evaluate. So I'm going to put a little here and just note that we can evaluate. And it's exciting, so I'm putting an exclamation point. And when I evaluate this, what I learn is that this is equal to 2. You're probably asking yourself, why? Why does it work that way? Well, because 6 squared, or 6 to the second power, is equal to 36. Forgot the 3 there. So that is why. And that's how we use the product property to condense or make things smaller. We can also use the product property to make things larger. I'm going to look at example 7 here. I am going to write this as, there are 2 terms here. So I'm going to need 2 log statements. They are both going to have the exact same base because that's one of the criteria. And I just break apart that multiplication. I put a 9 in one of them, an A in the other, and I'm going to remember that these are being added. And that's called expanding my expression. Put that note over here. Expanding means that we are making it bigger. And folks, that's how we use the product property. Logically speaking, I hope it makes sense that if we have a product property, we also have a division property. And we do. The division property here says that I can take log base b of a quotient, and I can break that into 2 different logs where I have the numerator in the first position and the denominator in the second position. And these log statements are separated by a subtraction sign. As with the product property, you must have the same base when condensing in order to use this property. An example of this property might look like log, let's try base 5, because we haven't used that yet. And then up here, I'm going to put some sort of division statement, x divided by 2, just for grins and giggles. I can rewrite this as a subtraction statement by breaking it into 2 different logs. They both have the same base, because that's a criteria, and I put the numerator in the front position and the denominator in the second position. And folks, order definitely matters. It's very important when using subtraction that you always put the numerator in the first position. And that's how we can use the division property to expand. In this case, we made it bigger. We expanded it into a subtraction statement. Let's look at one where we can condense or make things smaller. In this one, the first thing I have to check is to make sure that my bases are actually the same, and they are. They're both base 5. So I'm going to condense this and make it into 1 log statement. Log base 5 of 100 divided by 4. And again, because y'all are brilliant, you've already done that math in your head, and you're saying to yourself, but Ms. Palmer, we can write that as log base 5 of 25. And as before, sometimes we can evaluate these, and sometimes we cannot. We could not evaluate this statement, but we can evaluate this one because first, before I ask why am I allowed to evaluate this one? Because I know that 5 to the second power is equal to 25. Then I am able to evaluate this log statement and say log base 5 of 25 is equal to 2. We can expand, as we saw in this example up here. Let's do a real quick, easy one. Log base 7, I'm going to write this as 2 log statements. They will both have the exact same base. And I always remember to put the numerator in front position and the denominator in the second position, and I separate them with a subtraction sign. And that's how we use the division property.